Hello, welcome to the GATE 2021 CE Set 2 question number 19, which states that a solid circular torsional member OPQ is subjected to the torsional movement as shown in the figure, that is 1 kN meter and 2 kN meter over the shaft, let's say 1 and 2. The yield shear strength of the constituent material is 160 megapascal, it's given, and we need to find the absolute maximum shear stress in the member. Round off to 1 decimal places. Also, the respective dimensions of the shaft 1 and 2 is being given in the diagram. In order to learn the basics, you can go to the NPTEL course Solid Mechanics Lecture 18 Torsion 1 by Professor S.K. Bhattacharya of IIT Kharagpur. So before solving this question, let's see the formula that is being used here. So for a torque acting over the shaft, we can derive the torsional formula, which is given by T over J is equals to tau over R is equals to G theta over L. This formula is being derived on some basic assumptions, that is, circular section remains circular before and after the loading. The material follows the Hooke's law, that is, stress strain variations are linear, and the shaft that is loaded by the torque or twisting couple should be acted on a plane which is perpendicular to the axis of the shaft. And obviously there is a basic assumption that material is homogeneous and anisotropic. Let's see each term in this formula deeply. Here we have the shaft in which the torque is acting. This is the axis of the shaft. Torque is acting on a plane perpendicular to the axis. R is the distance of the point at which we need to find the shear stress, and theta is the rotation or angular twist because of the torque. Here we have the length of the shaft, and polar moment of inertia, as you already know, is given by inertia about xx plus inertia about yy. So in order to solve this question, we will use our torsion formula. Tau over R is equals to T over J is equals to G theta over L, where we can use this relation to move further. So it will become tau is equals to T over J into R. Since we need to find the maximum shear stress, so here R will be is equals to D by 2, that is the radius of the shaft, and the polar moment of inertia, that is J, as I already told you before, it's the inertia about xx plus inertia about yy, and we know that the inertia for the circular cross section is given by pi d power 4 upon 64, and because of the symmetricity is the same inertia about y axis. So our polar moment of inertia will become pi d raised to power 4 upon 32, and we'll put this value over here. So what will we get? It's tau max will be is equals to T times D by 2 over polar moment of inertia is pi to the power 4 over 32, and solving this we will get tau max equals to 16T over pi d cube, and this is the final formula that you need to be remember. You can directly remember the result for finding maximum shear stress in a circular shaft. Now let's just directly dive into the solution. So for the given question, we'll draw the FBD, free body diagram of the structure, in which there are two shafts, that is shaft 1 and shaft 2, and using the right hand thumb rule we can get the torque direction outward. Means by curling your finger in the direction of the torque, the thumb will give your torque direction. Hence this is 1 kilonewton meter. Here also it will be 1 kilonewton meter. This is shaft 2 and this is shaft 1. Because of Newton's third law, there will also be 1 kilonewton meter acting here, and already there was 2 kilonewton meter acting anti-clockwise. So this is also going to be act in outward direction. So this is 2 kilonewton meter, and combining these two it will be 3. So over the shaft 1 our final torque will be acting 3 kilonewton meter. Now the maximum shear stress can be calculated for both the shaft, right, using the same formula. So it's tau max 1, tau max 2, 16t over pi d cube, right? Again this is 16t over pi d cube. This is for shaft 1, torque at 1, this is torque at 2, and diameter of the second shaft. Let's plug in the values. So tau max 1 is equals to 16 times 3 into 10 to the power 6, since we are converting all the units in Newton and millimeter, over pi times diameter given as 0.1 meter, so 0.1 into 10 to the power 3, a whole cube. Similarly here tau max 2 will be is equals to 16 times 1 into 10 to the power 6 divided by pi into 0.08 times 10 to the power 3 whole cube, and calculating these values we will get tau max 1 is equals to 15.278 megapascals or Newton per millimeter square, right? And here tau max 2 will be is equals to 9.947 megapascals. And comparing these two values, we can see that absolute maximum shear stress is tau max 1, which is 15.278, and hence this is our answer. Thank you. Keep learning. All the best.